kind of science do you do?
My thing is to try to get more local kids interested in pursuing the marine sciences. So I'm tasked with trying to translate the research that we're doing in the Northwestern Hawaiian Islands to the public and to K through 12. So that's my mission here. I went to UH and after I changed my major from business to zoology, I got a bachelor's in zoology, a master's in zoology, and then I went to California to do a PhD at UC Berkeley, and I studied Hawaiian bottomfish in the main Hawaiian Islands and the Northwestern Hawaiian Islands.
I was recently hired by Albert Takon, who is now the aquaculture coordinator for University of Hawaii System. And this is his lab here at HIMB. And our focus will be to look at native species only. Ornamental fish like yellow tang, flame angel, these fish there's a high pressure on them from collectors, meaning that people go out and collect them from the environment and they're not able to sustain themselves. Their numbers are decreasing rapidly. This is a reason we want to focus on native fishes. Also, we'll be looking at food fish like moi and kahala, and hopefully doing aquaculture studies with them here. So this is one of our research tanks. We keep some of our older fish, or adult fish, sort of maintain them for different experiments. And right now I'm just going to feed them, give them their daily feeding. It's morning time, so they're hungry.
Hydrology, especially today, is pretty broad. It has to do with anything to do with water, really. I tended to focus on groundwater, which is the water that goes underground. But I also work with everything from how rain forms, how it impacts the trees, how trees take it up, how the ground takes it up, how the rivers take it up, its pathway from the mountains to the ocean in its different forms, whether it's streams or underground.
And what I do is I carry my equipment into the Office of Physicians and I do ultrasound testing of the heart. And I take pictures of the heart, do measurements, and then I give it to a cardiologist to be read.
Probably the most interesting to you guys is that I work on how lava flows and how lava tubes form and how they work. And so I have to watch a lot of lava tubes and lava flows. One of the things I do every week is I go out and I measure how much lava is coming out of the ground. And the way I do that is we find out where the lava tubes are inside the lava flows. And I do this measurement across the top that measures how a radio wave gets sort of screwed up by the conductive lava inside the tube. I measure how much it's screwed up. That tells me how much lava is in the tube. And then sometimes these lava tubes have skylights or pukas on the top of the tube where you can see the flow inside. And I take like a radar gun like policemen use or like they use to time baseballs. And I point the radar gun inside the skylight and it tells me how fast the lava is flowing underneath. So if I know how much lava is in the tube and I know how fast it's moving, I can figure out the output, like in gallons per minute. And the average output of the eruption these days is about, it's actually kind of low. It's maybe, I don't know, 30,000, 40,000 gallons per minute.
At the Coral Reef Ecology Lab, we're interested in the coral reefs. And the coral reefs involve a wide variety of things. And leading scientists now know that there are major impacts that are going to be affecting coral reefs in the future. And these are not only global impacts, but also local impacts as well. So we're trying to address these problems. And two of the main problems with coral reefs globally have to do with global climate change. One has to do with anthropogenic or human-induced atmospheric gases, mainly due to fossil fuel burning that is going into the atmosphere, and it is raising the atmospheric temperatures. It's also raising the ocean temperatures. So global warming is affecting our coral reefs as well as many other things. So we're looking at how corals grow under different temperatures, what species of corals will tolerate which temperatures best. Healthy corals, like this mushroom coral here, have a nice coloration, and much of our reef comprises of healthy corals. We're very fortunate here in Hawaii. Local problems such as sedimentation, eutrophication, and other stresses, overfishing, can actually change the corals to look more like this. When they start to stress, they lose some of their coloration from the tiny symbiotic algae within them, and algae starts to grow on them.
Currently I'm working on several different projects. Science-wise, I'm working on projects involving the largest scales in the universe. I'm very much interested in how galaxies are placed throughout the universe, and I've been working for many years on that particular project. And in order to do that, I have to look very far away into very far recesses of the universe. And so I've also been very much interested in active galactic nuclei like quasars and very bright things, very active galactic centers. And I use them also as signposts in the universe to measure the rest of my projects.
Compliance archaeology is more my focus. So in compliance archaeology, there are projects that are proposed by, say, maintenance, or let's take a different one, resource management. They want to go into an area and they want to plant, native plants, or they want to seed, an area. And that involves ground disturbance, so they've got to dig holes in order to plant the plant. I go out there ahead of time and I check out the area and make sure they're not going to be digging archaeological sites or tromping through areas that have archaeological features. So I go out there and I recognize whether those features are there or not.
They're trying to preserve like the eggs and the sperm of the fish for future, like, so you can start creating more fish. And so like once they've got that down, they can go on to the endangered species and preserve some of those.
So when I was hired at the Nature Conservancy, I was hired as their ecologist. Moreover, I was hired as their community ecologist. That is, not a community of people, but the community of living plants and animals that form these different kinds of forests and shrublands and grasslands that you can find across the islands. It was my duty to identify and describe the many different kinds of ecological systems that you can find in the islands, from coast all the way up to the summits. And so I was set loose in the islands to explore all of these places. I have been to so many remote locations where you're dropped by helicopter and then have to hike all the way back down to civilization. And along the way observing which plants and animals and what kinds of natural communities they form. In the end, we found that there were over 200 different kinds of distinct ecosystem types in the Hawaiian Islands, and that nearly all of them are ecosystem types that are found nowhere else on Earth.